Hi all, welcome to Learn Code Repeat. So today is the day 14 of the October LeetCode challenge. We'll be looking at the problem called House Robber 2. So let's look into the problem. So the problem says you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. All houses at this place are arranged in a circle. That means the first house is the neighbor of the last one. Meanwhile, adjacent houses have a security system connected and it will automatically contact the police if two adjacent houses were broken into the same night. Given a list of non-negative integer nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So exactly 1 month ago, that is on 14 September LeetCode challenge, the same problem first version was asked, which is house robber. So I would highly recommend you to look into that video. The link will be posted somewhere here at the top or in the description below. The video explains in detail how to solve that problem using dynamic programming approach, and we'll be continuing today from that solution onwards. So before I summarize that solution, if you want, you can pause this video and please go to that video and check out the detailed solution to understand the dynamic programming approach, and then come back to this video to understand the solution. Okay, so to summarize that question, right? So in that question we had, let's say here, right, let's take this particular case, right? 1 2 3 1. So these are 4 houses. What the question says is you have to rob the house such that you cannot rob the adjacent houses, because as soon as you rob the adjacent house, alert will go to the police. So you need to rob the houses but not the adjacent ones, and you have to make sure at the end you get the maximum profit. Okay, that is, you get the maximum amount of money, right? So that means if I rob, for example, this house first, and then I cannot rob this, then I can only go to this house, right? So it will be either 1 3, or it can be 1 and 1, okay, or it can be 2 and 1, but not 2 3, because these are adjacent, right? So in this case what we did was we found out at this particular place, right, when we are at index 1, right, what is the max profit that we can have, or the max money that we can have. So here it will be only nums of 0, right? So 1 will be nums of 0, okay. Let me call it as profit 1 equal to nums of 0. Profit 2, when I am at this position, right, when my index is at this position, it will be either I can choose this or I can choose this, right? Whatever is the maximum I will choose at that point, right? So it will be max of nums 0 comma nums 1. So the first two is very simple, right? But what happens if my position is this, if I am at the second index, if the index starts from 0th index, right? So if this is my I value, which is the index value, at this point I can select this current value plus the non-adjacent previous value, okay. So I can select this. If my current position is at I, so I can select this along with the previous non-adjacent best value, right? So the best value at this point will be, let's say this is, I am in a for loop, so I can say my max equal to max of, if I am considering current, nums of I plus my previous, right, previous will be, let's say I starts from 2, right, index 2. So 2 minus 2, right, here we cannot do 2 minus 1 because that will be adjacent, so we have to do 2 minus 2, okay. So 2 minus 2 is nothing but p1, right? So num of I plus p1, or I can directly select the previous best, right? Previous best was p2, right? So this is my max, and then I change the positioning of p1 and p2. So now I will say that my p1 equal to p2 and p2 equal to max, okay, and this I will do it in a for loop, okay, and at the end we can directly return max. So that way we can use dynamic programming here to find out what is the best max value, okay. This was the earlier solution, so this is a summary of that earlier solution. The difference here is instead of a normal row of houses, here they have said that the last house points to the or is a neighbor of the first house. So, it is in a circle, right. So, that means if I am selecting the first house, I cannot select the last house here. Okay. So, if I am starting with first, I can only go till the last minus 1. Okay. So, if I am starting with 0th index, I can only go till n minus 1 index, or rather n minus 1 is the last element. So, it will be n minus 2 index, right. So, in that case I am not considering the last element. So, that is one case. Second case is I can consider the last element, but since I am considering the last element, I cannot consider the first element. So, that means I can only start with 1 till n minus 1. Okay. So, these are the two cases that we can have, and using the same logic from the earlier problem, we can do this for loop twice, one for I equal to 0 to n minus 2, second for I equal to 1 to n minus 1, and then we take a max of these two answers, and that will be the answer for this particular problem. It is exactly same, it is just how you choose the start and end point, because the start and end point are now neighbors. Okay. So, I have written down here the previous solution. So, this is where we stopped last time. The house robber solution was this, and we will see how to continue from here, right, how to modify the solution to get the answer for this particular problem, right. So, here I will quickly go over the solution again. So, if my nums dot length is 1, then I can directly return that number, right, that will be the max value that we can have. If it is 2, then whatever is the maximum between 1 and 0, we can return that. We can choose either of that and return the max of that value. Then if my nums dot length is 3 or more, in that case we will do this logic, right. So, here again dp of 1 is nums of 0 and mat dot nums of 0 and nums of 1, right. So, let me take this out in a function. So, I have copied the exact same thing from here to here. Now, the difference is we are trying to make this a little generic, right. So, instead of 0, I would say start here, and here also I will say start, and here it will be start plus 1. Okay. I also will be start plus 2, right, and nums, instead of nums dot length I will say it is less than end. Okay. Now, the rest of the things we can keep it exact same, and here instead of this I can remove this and I can simply return here mat dot max of nums comma. Now, first I will start from 0 till n minus 2. Okay, n is my nums dot length. So, nums dot length minus 2 mat dot max of here it will be find max. So, this comma again find max, but this time it will start with 1 and it will go up to nums dot length minus 1. So, that is the only change that we have to do in our previous solution, and the rest of the things will be same. So, let us run this code. And the test cases passes. So, let us submit this. Okay, here we are doing till that point, right. So, it should be less than or equal to. Let us submit this and the code is accepted. Okay. So, similar to the previous problem, the complexity of this will be O of n, since we are going through the nums only once. Actually, we are going through it twice, but since it is 2n, so it is same as O of n. And the space complexity here we are not using any additional space. So, the space complexity is O of 1. So, hope you like the solution. Please do subscribe and hit the bell icon for all notifications on the channel.